Hello everyone, this is the video lecture for pre-calculus sections 4.1 and 4.2. They're actually together on the homework. And it's also a very short sections on the homework. This will be very fast actually. So exponentials, let me just remind you what's going on here. It's probably not the best looking graph. There we go. Exponential growth. So it grows, or we can have exponential decay. And it generally looks like, I don't know, f of x is equal to b to the x. And b is my base. And so some easy ones are like 2 to the x, 10 to the x, e to the x. We've done e's before, hopefully in your college algebra class. Of course, we could put minus signs and all this kind of stuff in front of it, but that's just the basics. So exponential growth and decay. Let's just get started with some problems. So for 1002, we got some, I think it's a matching problem. Now again, there's some of these problems I haven't seen in quite a while. I didn't just go to WebAssign just now. I have all my good notes though, from my last semesters. And I have these graphs on here, and apparently I was just matching them up. So, well, there you go. So that was a base of 2 to the x. This is like your basic, what your normal graph would be. And then we just have the transformations, reflecting it about axes, etc., etc. So I wouldn't worry too much about it. I don't put a lot of time into it, so it's probably not that big of a deal. 41013. So they start with f of x is equal to 1/4 to the power of x. Notice this is my base. My base is a 1/4. If my base is greater than 1, that's going to be growth. But if my base is less than 1, in this particular case, it's decay. So like I can already tell you it's going to look something kind of like that. That's kind of like my basic graph of what this will look like. I don't really cared about the graph right now, but I just wanted to say, you know, this 1/4 is a legitimate base. You won't ever have a negative though. This number won't ever be negative, so don't worry about that. Negatives, they actually just don't exist. They don't work. So just don't do that. So x equals -2. They're wanting you to plug that in for your x. Again, that would be now a -2 up there. Honestly, I would just use calculator, honestly. And if you have an older calculator, you could do something kind of like this here. Notice that's a negative, not a minus sign. In particular for the TIs. The Casios, I think, don't matter either way. So that's another way to do it. You can do it this way, and the new fancy calculators is fine. Scientific graphing, whatever, doesn't really matter. It's just calculate. But what is really going on behind the scenes is that this is a negative power, and so what it's doing is actually re-flipping it. I guess you can kind of say that this is 4/1 now, squared. Well, like 4/1 is just a 4, isn't it? Well, what's 4 squared is 16. That's what's going on there, okay? They want you to repeat this again and again, so find... I guess I could have said right here a -2. That would make more sense. So f of -1, you do the same thing like this. Again, the negative flips it. There's nothing else to do there. It's just a 4. And so on and so forth. I'm just going to real quickly then give you the answers to these guys. A 1. Oops, that's an equal sign right there. When you plug a 1 in, I got a 1/4. They're basically the same. If you put a 1 in for your power, nothing changes. And if you square it, you get 1/16. Notice that we had 16 over here and 1/16, 4 and 1/4, and 1's kind of like in the middle. So it's kind of like a symmetric kind of action, I guess you can say. Something like that. Okay. I wouldn't put too much into that. I'm just showing you, hey, can you complete a table? So 41023. We have f of x is equal, if I could rewrite my x a little bit better, is equal to a to the x. That's a lowercase a. They give you this graph, and it's touching at 1, and it's also touching at another point right here. They say is 2, 1/16. 2, 1/16. technically we got 2 points, but honestly, this 1 is just a verifying that this is our basic graph. We don't have some other kind of number in the front here. That number's a 1, therefore it's a 1 right there. That's basically what's going on, okay? So, not as helpful as it would normally be, but this guy's very helpful. I'm going to try to solve for a, and that way I can have what my graph, my function truly is, okay? So how do I do that? Well, this is an x, this is a y, this is a y, and that's an x. So I got y is equal to little a to the x power. Well, that means I got 1/16 is equal to a squared. See, I'm just plugging that in. So where do we go from here? How do I solve for a? Well, I think the easiest one, just between you and me, is just going to be the square root. Just square root them. Now, I know that my a has got to be a positive. It must be a positive answer because I just told you about that. You can't have a negative base. A must be a positive answer. So that's reassuring. You don't have to put a plus and minus here, or it's just you'll get a positive. We're good to go. So what is the square root of 1/16? That's kind of the question here. Well, you can distribute that like this. I guess I'll put a on the other side now. Well, square root of 1 is 1. Square root of 16 is a 4. So that's our base. That's our base for the exponential. Cool. So then, what's my final answer? Again, I'm just rewriting this. So y equals 1/4. That's my a to the x power. What they want on WebAssign is actually you to type that whole thing with the y equals. I mean, that's at least what I have boxed in. If I'm wrong, well, I'm wrong. But that's what it seems like to me. 41053. This one's a word problem, kind of. They're talking about bacteria. Hopefully I spelled that right. We had 1,300 initially present. I'll put initially. That's a pretty good way to do it. And then they're supposed to double each hour. Sounds kind of scary, doesn't it? Wow, that's pretty fast. I don't know if that's normal or not. So this is how... Here, let's just back up for a second. They're wanting you to find a formula for this, and then they're saying, okay, well, now plug in a 24 for your t and see what happens. Notice that my independent variable is a t, not an x, so they're talking about t for time. What would be my answer? What would be my function for this kind of situation? Let me go back to a formula. Like we had the y equals b to the x. That's the most basic one. When we start talking about applications and stuff, maybe you notice this one, a equals a naught e to the kt. This is something that you saw in college algebra. It's kind of like the basic application style something or other. And maybe, if you remember, the PERT formula for compound interest, it's the same thing, right? So that's for money. This is for, I don't know, half-lives and I don't know, interest rate stuff, I guess. In this case, it's bacteria. It's whatever. It doesn't matter. So we got this formula. Well, this A naught, even the P, is the initial amount. And you can see initially is the 1,300. So I got 1,300. And then I got like E to the KT, right? Well, to double each hour, I'm going to be straight with you. You could go and find out, like, well, now this is like 2,600 and solve for K and blah, blah, blah. That's fine. You'll get some long decimal or whatever. I think there's a much easier way to do this, and that's kind of why I'm telling you, you don't have to go about with this E stuff every time. We can kind of go back to our plain old B here. I'm just going to say 2, and then to the T. This is your answer. You're taking your initial amount of 1,300, and you're doubling it times 2 every time you have an hour. You can go and plug in t equals 1. What do you get? T equals 2. What do you get? And you'll see that you do actually indeed are doubling each hour. Much easier than trying to solve all that stuff. Don't do that. I would just plug this in. You're good to go. So for the 24, you're just going to plug that in. And, I mean, I couldn't do this without a calculator, honestly. I can count powers of 2 pretty well, but, I mean, not up to the 24th power. You get past my 10 fingers, that's over. So I got a super, super huge number. 2.18108 times 10 to the 10th, or you might have like E10 or something like that in there on your calculator. That's huge. What are you supposed to do about this craziness? I'm going to show you exactly what WebAssign wants. So here we go. It's a 2, 1, comma, 8, 1, 0, comma. The commas just help me because, like, there's a lot of numbers here. This guy, and then an 800. This is what their answer is. That's what they have. As far as commas, I'm not really sure if that's exactly allowed or not. I would try it. You know, WebAssign's pretty forgiving. If it doesn't like the commas, if it says, I don't understand what you're talking about, just take the commas out. You know, just put the number. The number is fine. So I'm using the commas, obviously, just so we can see just how big this thing is. Well, the point of how to get from here to there is that we got 10 times we have to move that decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. And you're going to put zeros in the remainder places. You can see that's a pretty huge number. Now you're seeing that, like, see that 8 right there? I didn't include it because I was just being lazy here on my calculator. I just stopped at this point. But really, my calculator did keep going. So yours should as well, okay, to make all that happen. Now be prepared, okay? Get a really long answer there. Okay, keep going. And of course, if you got questions or you're confused about how something's working, you can always send me the Ask My Teacher stuff. You know, I'll look at it, we can talk about it, etc. I'm always here to help. So they're talking about money here. We got an initial amount of $5,000. And I think we're compounding monthly. And they're wanting to do this for 3 years. What they haven't told me is the rate. So they actually have Part A, Part B, a 1% rate, and then a 2% rate. All right. So the idea is that you got $5,000 just sitting around, and you're going to go to a bank, and you want to say, hey, I want to make some money on, you know, interest, put it in a CD or something like that. Certificate of deposit. So you put it in there for 3 years, and you know they got different kind of rates. You're shopping around. You found a 1% rate. You found a 2% rate. Obviously, we all know that the 2% is gonna be better. But like, what would you get from these guys? Okay, if you did go with the 1% or 2%, is it really worth changing banks over this kind of stuff? So let's go and find out what that would be. So the formula is A equals P times 1 plus R over N all to the NT. This is old school stuff. You should have seen this before. If not, well, there you go. Basically, I'm just going to toss it all in here. As a reminder, this is my final amount, A amount. P is your principal. But we've already talked about that a little bit in the last one, where it's our initial amount. 1 plus R is my rate. But rates are always in decimal form. So you're not going to just put a 1 in there. You're going to put 0.01, you know what I mean? 0.02. T is, of course, years. That's super easy. And then N is kind of interesting. It's the number of times compounded per year. What I mean by compounded is basically just how many times are you looking at it monthly. N equals 12. 12 months a year. Every month you get a statement in the mail, says this and that, da-da-da. So that's what they're talking about. Okay, so how do we get all this stuff done? We're just going to plug it straight in. 5,000 times 1 plus 0.01 divided by N is always a 12 here. And then 12 times T is a 3. Calculator. All at once, calculator. And I'm just going to tell you here. It's 5152.21. I'm pretty sure they're wanting the dollars and cents, so stop at 2, obviously. Repeat for the other guy, 0.02, put that 2 right there, 12, and then 12 times the 3, and I got 5308.92 dollars. So you get an additional about 150 bucks extra for a 2% rather than 1%, so that's nice. Okay, cool. One particular thing that often happens right at this moment is that your calculator is probably different than my calculator, or you type stuff differently than me. If you have a really cool new fancy one, I call it the pop-it calculators because they pop up whenever you do a power. You just go and type, and it's like really fun, small text all on the top, the superscript stuff. Then you're just good. Type whatever you're seeing here straight up, and you're good to go. But if you have an older one, like I have an older one here, like a TI-83 or something like that, what it looks like is 5,000 times 1 plus the 0.01 divided by the 12, close, power, open, 12 times 3, close. Notice that I'm keeping that entire power in parentheses. Another suggestion is that you could just simply say 12 times 3 is 36, and so blah, 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 the same thing, power 36, and it's much easier to type. So either way, if you're better with calculators and you're okay with parentheses and stuff, 12 times 3 is totally fine. But if you're like, man, I'm just every button is like a problem for me, well, just do a little bit of math before, and for the power in particular, and then you can get that a lot easier. I recommend both. Both are great. Okay. So now you're learning little tricks about calculator stuff also. So number 61, I got A is equal to P times 1 plus R over N to the NT. I figure that they gave you that formula in this particular problem, but not up here. Kind of aggravating, but anyways, just a guess there. We'll be using it again. So we got $10,000, and they call this the present value. Present value. Okay, that's a little different than what we have so far. I'll talk about it in a second. So we got semi-annually. That basically means n equals 2, 2 times a year. They got 8% rate, which we all know is going to be 0.08 at this point. And then they're saying do it for 2 years. So that's going to be my T. So good, R equals that, good, and good. Okay, so we got some numbers. Awesome. What is our present value? Well, it's kind of weird. This is actually your answer, your final amount. What they're wanting to do with this problem is they're saying, I need $10,000 in 2 years. I need $10,000 in 2 years with this certain bank account with 8% rate. How much do I need to invest today in order that 2 years from now I would have that $10,000? Maybe $10,000 is a down payment on a car, or maybe even on a house or something like that. So I need that $10,000 in 2 years. I got to have it. So what do I have to do in order to get it? Well, we're going to go find out what I have today, what I'm going to have to put in the bank today in order to get that. So it's kind of pretty applicable. This is good math. So here we go. I got the 10,000 equals P, which we're going to try to find. That's my my principal, my initial amount, the one I have right now. I know it says like present value, and it kind of like P present. No, don't think like that. Final is probably a little bit better. 0.08 divided by the 2, and then 2 times T is 2 years. It's kind of funny we got 2 2's right there. Again, if you want to do this in the calculator, like, 2 times 2 is just 4. You can do power 4. It's super easy. Well, all of this is one big number. It's a big decimal. I'm going to divide it over there, so that my P is equal to 10,000 divided by, open 1 plus, 0.08 divided by the 2, all to the 4 power. I'm going to do the 4, just as easier. Calculator. You could have found this as a decimal, and then you could just say 10,000 divided by answer in your calculator, if you have like the answer feature. I'd say most calculators have that, even like scientifics and stuff. So lots of different tricks to get this thing to work. On a side note, and I know this is being recorded in the year 2021, an 8% interest rate is super high, and so if the bank is giving you money like this, that's awesome. You like 8%, especially when it's so secure like this. It's not like stock market-y stuff. I think, I don't know, again, just offhand, I think interest rates for like CDs at banks and stuff is less than 1% probably right now. It might even be negative. I don't know. That was a joke. I don't know. But it's tough. It's tough to get a secure bank CD like that. Okay, so This is what I got from my calculator just now. Basically, I have to put in the bank right now $8,500 in order to get $10,000 out of it here in 2 years. Okay. Now, I'm going to tell you that WebAssign had their answer as 8548.05. Now, I'm looking here at my calculator. The next number here is a 191. So that would not round. Okay, that doesn't round. I don't know why they got the 5 there. It's kind of interesting because I am doing the homework, but they give me the answer ahead of time because I'm the instructor. They just let me do that. That's fine for me. So I didn't actually get to test to see if a 4 cents would work rather than a 5 cents, but I'm pretty sure that it has a plus or minus margin of error already built into the problems, and so it should be fine either way. Again, just like always, if you're having some kind of issue, and this would be a technical issue if it wouldn't accept the 4 cents, not the 5, you tell me, and I go, yell at tech support and all kind of stuff. I got connections. So 42023. Another word problem. They're talking about blood, a drug in the bloodstream. Not bad drugs. We're talking like medical good drugs. And they give me this formula for the amount of drug. I don't know if it's like milligrams or grams or something or other in the bloodstream, and they want to know what's going on at 3 hours. Well, I mean, I just plug it in, don't I? So, yeah, it's like super easy, and I think I included it just because sometimes we're doing such crazy math that I think I overthink it. I think, oh man, there's no way it's so easy, and when it really is. So 44.44909. So after 3 hours, that's how much, I don't know, percentage or milligrams or whatever it was would be in the bloodstream. Cool. This is actually the very last question that I have for this video lecture. We have $400 invested. Okay. I have a rate of 2.5%. It says per year. That's interesting. Of course. I mean, I don't know. That's normal. That's our rate. That's good enough. And then 12 years. So they got two different ends, two different compounding amounts. So we have annually, which would be n equals 1 time a year. And then we have the semi-annually, which would be n equals 2. Again, just kind of like more ideas and options. If we had monthly, we'd have n equals 12. What about weekly? 52. What about daily? I think 365 works. I'm pretty sure. And just in case, way down, let's just say, I don't think it's a part of this problem, but if they use the word continuously, then that's basically n equals infinity, and that's when we take over with the PERT formula instead. So this is the old formula we've been using. The PERT formula would be only if it says continuously. Anyways, this is a super easy problem. So I'm going to say the 400 is my principal, my initial amount, 1 plus 0.025 for my rate divided by 1 to the power of 1 times 12. And obviously 1 times 12 is, well, just 12. Put it in the calculator, I got $537.96. And the last one, 400, 1 plus 0.025 all over 2, all to the 2 times 12. Again, all at once in the calculator like we've been talking about, 538.94. Now let's compare these really quick. I want to talk about it. I do this in my algebra class all the time. Notice that between annually and semi-annually, what you gain was $1. $1. You gained an extra $1 over the last 12 years. $1 difference. Ultimately, that doesn't seem like a lot. Like, whoa, what if I did it monthly? Maybe I'll make a lot more. Not really. The idea is that you're going to be making about the same, regardless of how many times it's compounded, roughly. Of course, it is better to compound more often, so your continuously would give you the maximum. which is probably still around the 540 range, just guessing here. So you're not really going to get higher than a certain amount. But there you go. We're done with this lecture. Thank you very much. Have a great day.